Welcome back to MCP Mesh. In this tutorial, we will take our locally running agents and deploy them to Docker Compose, then build a truly intelligent agentic application with dynamic tool discovery, graceful degradation, and LLM provider failover. Let's get started. From our previous tutorial, we have two agents created and running locally. Now let's deploy them to Docker Compose. Claude is using the scaffold command with the compose option to auto-generate a Docker Compose file. The scaffold command scans the directory, inspects all agents, and automatically creates a Docker Compose configuration with the correct settings to deploy them. When we used Scaffold to create the agents, it automatically generated Docker files and Helm values for them. The Docker files use the official MCP Mesh Python runtime, which has the SDK pre-installed and optimized for production. MCP Mesh also provides official Helm charts, so going from local development to Docker Compose or Kubernetes is straightforward. Build your agent locally, containerize with one command, deploy to any environment. Production ready from day one, not as an afterthought. And with one command, all agents are deployed to Docker Compose, containerized, abstracted from your local configuration, reflecting true production behavior. Claude invoked the tools and confirmed everything works in Docker Compose exactly as it did locally. No code changes, no complex setup. You can switch between environments seamlessly. Work on the whole application or focus on just one agent. MCP Mesh gives you that flexibility. Now, let's make this a truly AI-powered agentic application. We'll add an LLM agent to the network that can use the tools we developed earlier. Unlike other frameworks, MCP Mesh requires no complex orchestration between tools and agents. Remember the capabilities and tags we used earlier? MCP Mesh provides a filter mechanism to discover all tools an LLM agent can use and automatically injects them into its tool list. Filters give you both flexibility and fine-grained control. No hard coding required. The tool list is dynamic. As new agents come online or existing ones become unavailable, your LLM agent adapts intelligently. Running Mesh Cuddle status confirms that MCP Mesh has made all tools available to our LLM agent. Declarative configuration with full observability into what's happening under the hood. Claude asked the smart agent to greet, and the LLM agent used the correct tools to retrieve the information. All we did was set the filter mode to asterisk. No tool call logic, no iteration handling, no response processing. MCP Mesh handled everything for us. Let's ask the smart assistant about the weather in New York. Since this requires real-time information and no weather tools are available, it shouldn't be able to answer. This confirms our LLM agent only uses the tools available to it and doesn't hallucinate or make things up. As expected, the smart assistant doesn't have any tools for real-time weather data. Let's add a weather agent to the mix. We'll use WTTR.in, a free weather service that provides comprehensive weather reports. Our weather agent will expose two tools, Get Weather by City Name and Get Weather by Zip Code. The data includes temperature, humidity, wind speed, and feels-like conditions. Once we scaffold this agent, MCP Mesh will automatically make these tools available to our LLM agent. Claude is scaffolding a weather agent with tools to query weather by city or zip code. You can test it separately, focus on the business logic, and return simple strings or complex types as needed. MCP Mesh will handle integrating this with your LLM agent when the time comes. Notice the requirements.txt file in the agent folder. The scaffold command creates this for you, so you can easily add your library dependencies. When building the Docker image, MCP Mesh automatically installs these dependencies. You focus on your business logic. MCP Mesh handles the infrastructure. The weather agent is ready and tested. It has two tools, Get Weather by City and Get Weather by Zip Code, returning rich data including humidity, wind speed, feels-like temperature, and more. Now let's ask the smart assistant if it can get weather information. And yes, it can. Notice, we didn't make any changes to the smart assistant or restart it. When the weather tools came online, the smart assistant automatically discovered and used them. Behind the scenes, The LLM requested a tool call. MCP Mesh routed it to the weather agent, executed it, and presented the results back to the LLM. Multiple tool calls, data serialization and deserialization, response formatting, all handled for you automatically. What would this have required in other frameworks? Let's stop the weather agent and see how the Smart Assistant handles it. It shouldn't throw errors when weather tools become unavailable. Here's what happens behind the scenes. Every agent sends heartbeats to the registry. When the weather agent stops, the registry misses several consecutive heartbeats and marks it as unhealthy. The LLM agent learns about this topology change during its own heartbeat cycle and automatically removes the weather tools from its available tool list, setting the proxy to none. This is graceful degradation in action. No network errors, no timeouts, no failed retries. MCP Mesh detects the unavailability, updates the topology, and allows your LLM agent to handle the situation gracefully. The best part? When the weather agent comes back online, MCP Mesh automatically rewires everything. No manual intervention, no restarts, no configuration changes. The mesh heals itself. Graceful degradation in action. MCP Mesh detected that the weather agent went down and removed it from the Smart Assistant's tool list. Instead of making calls and hitting network errors, the assistant politely responds that it doesn't have tools for weather information. Now let's add more redundancy and make this application truly resilient. We'll add ChatGPT to the list of LLM providers. Occasional unavailability of any single LLM service won't affect our app. Here's what makes this possible. In MCP Mesh, everything is an MCP tool, a simple function that returns the date, MCP tool, an LLM agent that reasons and plans, MCP tool, an LLM provider like Claude or ChatGPT, also an MCP tool. Why does this matter? Because everything becomes a first-class citizen in the mesh. There's no artificial hierarchy. You can mix and match components freely, swap providers, add redundancy, scale specific capabilities, all without changing your application code. Notice the plus sign in the provider tag? This lets us prefer GPT when available, while falling back to other LLM providers if GPT goes down. Smart filters in MCP Mesh enable deterministic behavior within a loosely coupled architecture. Your agentic application is now distributed, scalable, resilient, and unaffected by external provider issues, production ready from day one. From rapid prototyping to production deployment, MCP Mesh has your back. Ready to build your own LLM-powered agents? Install Mesh Cuddle, start with the Scaffold command, and deploy intelligent agents in minutes. MCP Mesh is fully open source under the MIT license. Check out the GitHub repo, star it if you find it useful, and join us in building the future of distributed AI agents.